Good timing, Tate. We're just getting started. Okay, here we go. Let's see how this one goes. All right, you guys, every time I give you a test, every time I give you a quiz, it's always the same thing. Here's a non-calculator. Here's the calculator. Well, guess what happens on Friday?
Nothing.
The same thing. Non-calculator versus calculator. Non-calculator, that's what we're doing right now, guys. So, guys, you are not allowed to touch your calculator in this section. So don't do it unless I tell you to, because I will tell you to twice, okay? Because it does say, at the end it says, go ahead and use your calculator now, okay? All right, so here's what you're doing. Today, whoops, I'm going to color red. Today you will do this. You will find what? Exact values. You will not get to type it into your calculator, even though your calculator would tell you the answer. You have to come up with it yourself. Of what though? Inverse trig functions. Now, inverse trig functions, that's this. I'm going to ask you this question. Something like that. What is the inverse sine of 1 over 2? Which means, when will the opposite side be 1 and the hypotenuse be 2? What angle does that for us? Does anybody know? Nobody? Oh, it is, yeah. But you didn't say which one. It's one of them. Okay. Ethan says it's either the 30 or the 60. It's not the 90. Okay, the 90. Well, it could be. But anyways, it's what? 30. You guessing?
No.
There you are.
I calculated in my head.
You did that? How'd you do that?
SOHCAHTOA.
Okay. All right. Well, here's the deal. You do have to come up with these answers, and he is right. Carr got it. He said 30. It is. I'll show you how to do it in just a second. But that's your goal, to do that. All right. Let's get started, though. It says using your calculator. I say you can't. Now I'm saying do it. Using your calculator, will you find this for me?
No.
Okay. If you don't want to participate, that's fine. Sine of 40. Do it.
Your calculator?
Yep, now I'm saying this is probably one of the few times I'll let you do it. Punch it in. Sine of 40 is, and I already know some of you already have it. Sine of 40 degrees is, it is a ratio. It's opposite over what? It's opposite over hypotenuse because it's sine. What'd you get?
6, 4, 2, 7, 8.
2, 7, 8. Okay, so 2, 8. Okay, so this is what you got. 0.6428. Okay. Now, when you punch in, listen closely. When you punch in sine, you always punch in sine of an angle, and then the calculator does this. Sine of 40. It knows 40 degrees is here, and then it says opposite of 40 over the hypotenuse, and it comes up with this number, 0.6428. And really, it's just a ratio. That's all it is. 0.6428 is over 1, by the way. So what it really means is this. There's your 40-degree angle. There's your y-axis. Okay? And it basically measures this side, the opposite, 0.6428 compared to what? The hypotenuse, 1. And that's really all it's doing. Just comparing the opposite side to the hypotenuse. Now tell me something about the hypotenuse in a right triangle. It's the longest side. It is by far the longest side. So this opposite side can never be bigger than the hypotenuse. And it isn't. It's 0.6, or a little bigger than 0.6. Okay? Now, here's the problem. The problem is that answer can come up again. There's another angle that will give us that same answer right here. What? Louder. 45. No. 45 would lift the line up a little bit more, and it would change this height. This height would change.
35.
35? No, it would lower the height. What?
40.
Negative 40 down here?
40.
Wait. Negative 40 would give me that answer, except it'd be 40 degrees down, not 40 degrees up. Here's what I was hoping you'd say.
40.
That answer is over here. The same triangle, if you reflect it over the y-axis, is over here. This 40 is now right here. Okay? Now if you compare this distance to this distance, remember the hypotenuse is really just the what? It's really just the radius of your circle. So will this height be the same as this height?
Yeah.
Yeah. So the answer is, again, 0.6428. But what angle actually gave it to me? 140. Yep. So this angle right here, guys, is 140. Would you do me a favor? Take sine of 140. What do you get? You get the same answer, aren't you?
Yeah.
Okay. So how many answers are there?
2, 4, 1.
No, there's not 4.
3.
Because these answers down here
Or negative.
will give us negative, because the y value would go down. So how many answers are there?
2.
2, but no, there are not 2. Okay, watch this. 40 degrees gives me 0.6428. So does
140.
all the way around.
360.
Well, add a 360 to a 40. What do you get? So 40 and what? 400 degrees. Go ahead, take sine of 400. What do you get? Same thing.
760.
This one would be 140. If you add another 360 to that, it'd be what? 500. Sine of 500. 0.6428. So how many answers are there? Infinitely many, because I can keep making circles.
Yeah.
So here's what happens. Here's what happens to inverse functions. Because there are so many answers, we have to restrict ourselves. We have to say, when we give answers for sine, where are we going to give answers? What quadrants? And that's what I'm going to do with you next. Okay. Same with cosine. Same with tangent. Okay. So let's go back here now. Okay. Now this should make a little more sense as I talk about it. Okay. Suppose you were asked to find the angle whose sine is 0.6428. To do this, you would use the inverse sine key on your calculator. Okay, so now what I'm asking you to do is this. Take inverse sine of that ratio. You're going to get what? You're going to get 40 degrees, aren't you? You're not getting exactly 40. You know why? That's a rounded answer. You're not going to get exactly 40, but you're getting close. So now, the answer is 40. But it says here, of course, sine of 40 is the same as sine of 140, which is the same as 400, 500, 760, etc. So there's so many answers. Your calculator was programmed to tell you this answer. Why? Why was your calculator told that? Because we have to get one answer for a function. So here's what sine is. When you punch in positive ratios, you're in what quadrant?
The first.
Quadrant 1. If you punch in negative 6.6428, you're going to be in quadrant 4. So inverse sine is defined positive ratios up here, negative ratios down here. So 1 for positive, 4 for negative. Okay? So that is where I'm going next. All right. Here, I'll read this to you. An inverse trig function can only give us how many angles? One angle measure. If that's the case, we have to restrict. We have to restrict what's coming up. It says if you plug in any a value for your inverse. By the way, this is a ratio. If you plug any ratio in for a between -1 and +1, then the inverse sine of a is, and I'm just going to show you, I'm not going to read all that to you, it's going to be this. You might want to write this. If I plug in inverse sine of a, all positive ratios will end up there, all negative ratios will end up here. Okay? So guys, when you plug in 0.6428, you ended up here at 40 degrees. If you would have plugged in negative 0.6428, you would have ended up where?
Negative 40.
Negative 40, exactly. Okay. So then it says this. Your theta, your answer, will be in degrees from where? 90 all the way down to -90. So you will say from negative 90, theta will be greater than or equal to negative 90, but less than or equal to 90. So between negative 90 and 90. In radians, that would be negative pi over 2 to what? Positive pi over 2. So basically, our answers are only between here and here. We do not even talk about that side. Okay, then we do what? Inverse cosine. And inverse cosine is kind of strange. This is the one you guys tend to get wrong on the test. This is the one where we find cosine to be between here and here. All positive ratios go in the first quadrant, all negatives go in the second quadrant, which means this is the hard one. When you plug in negative ratios, you have to figure out you're over here in the second quadrant. All your answers will be like 120, 135, 150. Okay, so where are we going from? 0 degrees to what? 180. So put that in. Theta must be greater than or equal to 0, but less than 180, or equal. In radians, it'd be 0 radians to what? Pi. Good. Inverse tangent. Oh, I should write this. When I punch in this, okay, my answers are between here and here. Okay, for tangent, inverse tangent, you'll be exactly the same as sine. Right here. Inverse tangent, when you do that, all your answers fall between 90 and negative 90. So start here, go greater than negative 90 and less than positive 90. Or if we go radians, negative pi over 2 and pi over 2.
So then when positive and negative in the same spots, positive on top, negative on bottom.
Yep. So Jessica, if I did something like this, let's just pretend I did this. Inverse tangent of 1 over 1. That ends up being a 45. That's the answer. But if I would have done negative 1, guys, inverse tangent of negative 1 over 1, that would end up being a negative 45. So when you plug in negative ratios, you get out negative. Down here, plug in positives, you get out positives. I'm going to show you in a second. Okay? What's most important is you just understand this. There's only one answer. Don't give me 2 answers, just give me 1. And then where are the answers for tangent and sine? First and fourth. Where are the answers for cosine? First and second. Just know that. Okay? Okay, now, would you do yourself a favor and do this? I need you to draw 2 triangles, 145, and draw yourself a 45, and draw yourself a 30, 60, 90, okay? And then label your legs. So in your 45, 45, your legs are 1, 1, square root of 2. When you get to the test on Friday, do this. Put this on the very top of your quiz. Then jump over here and go, okay, this looks like my 30. I'll call that my 30, this my 60. Opposite of 30. 1, opposite of 60.
16.
Square root of 3, right?
Yeah.
And the hypotenuse? 2. Okay. Just draw that and have that somewhere near you and keep looking at it as I ask you these questions. All right, here we go. Okay, here's our first problem. Evaluate the following expression without using your calculator. Give your answer in both radians and degrees. This says inverse cosine of what ratio? 1/2. But it's negative, isn't it? Okay, forget the negative for right now. To me, if we're talking cosine, it's saying the top number is the adjacent, the bottom number is what? The hypotenuse. Go find an angle that has adjacent 1, hypotenuse 2, and here I go, I'm looking here. Where do you see 1s and 2s? Right here. This is the one you should be looking at. 1s and 2s. Is it the 60 or is it the 30 for cosine?
60.
I'm hearing 60. Okay, let's look at the 60. Where's the adjacent side? 1. Where's the hypotenuse? 2. 1 over 2. Yes, you're right. It is 60 degrees. But the only problem is, it wasn't 1 over 2. It was negative 1 over 2. And it's cosine. Cosine is found in these two quadrants, right here. All positive ratios go here. All negatives go here. You had a negative. You should be doing this. 60 degrees. There's your angle that creates that ratio. Because this is your triangle. So you tell me, what angle is this?
120.
120, right here. Yep. Answer's 120. Can you tell me radians on that? Do you know it?
Probably 2/3 pi.
It's 2/3 pi. Good. Now Brady did that pretty quick, but I'm going to show you something. Here's all you got to do. Remember, 120 times this. Isn't this what we did? So we can just reduce it to what? 60 goes in there twice. 60 goes in there 3. And that's where Brady's getting the 2/3 pi. I'm not sure. I don't think he's doing it like that. I think he's just thinking it through. 60, 60, 60, 2/3 of pi. Anyways, so this is the answer. Inverse cosine of a ratio gives you an angle. You get angles today. Next up, take sine of 1/2. And is that negative? Yes. Inverse sine of negative 1/2 will be an angle. Let's go find it. Which one creates a 1 over 2? Opposite over hypotenuse. You looking at 30? Opposite over hypotenuse. That's what sine is. So it is your 30. Why didn't 60 work? Because the opposite of 60 is what? And you don't have square root, you have 1. So it's the 30. Okay, so let's go back. And now you got to say it's sine. Sine is found in this quadrant or this quadrant, right? This is a negative ratio. Positives up here, negatives down here. Where are we going to put our 30?
Negative.
Down here, right. So this is the triangle that gives us our angle. Now, you already told me it's what here? 30. You told me 30 gives, the sine of 30 gives us 1 over 2. All right, so what's the answer here? What degree? Negative 30, yes. In radians, what is that?
Negative 5 or 6.
Yes, negative pi over 6. You got it.
That's not bad.
That's your answer, right?
Yeah.
Hey guys, this is all we're doing. I'm not trying to surprise you. This is the same thing over and over. This time it's inverse tangent of what?
1.
1 over 1. Tangent is just opposite over what? Adjacent. Go find the triangle that would give you 1 over 1. Which angle? Is it 30? Is it 40? Is it 45 or is it 60?
45.
Yeah, look. Opposite. 1 over adjacent. 1. Oh, it's a 45. Okay. Was it positive or was it negative?
Positive.
It was positive. So where are we restricted? Quadrant 1 and quadrant 4. Positives up here, negatives down there. You told me what?
Positive.
45. That's what you told me. So you know the answer is 45 degrees. Tangent of 45 gives you 1 over 1. So the answer is 45, or better yet, radians what?
45. 4.
Pi over 4. Okay. Look at the next one. Square 3 over 3. You want to do what? Tangent. Tangent of what angle gives you square 3 over 3? You should be looking here.
6. No, wait.
30.
Okay. You say, I'm hearing 30s, and I'm also hearing 60s, by the way.
Negative
How many say it's 60? Okay? Opposite over adjacent. That's what tangent is. Ready? Opposite.
That's it.
Square root of 3. Over adjacent. 1. Is the square root of 3 over 1 square root of 3 over 3?
Yeah.
It is?
It's 30.
Thank you.
Because you gotta take.
I don't think so. I think this is just the square root of 3. You have the square root of 3 over 3. It's not 60. It's what?
30.
It's probably going to be 30. So let's look at 30. Opposite, 1 over adjacent, square root of 3. Does that look like what you have?
Yeah.
Well, not really until you do what?
Times the square.
Rationalize the numerator denominator to get what? Square root of 3 over 3. Oh, it is what I was looking for. It's a 30. Okay? So this would be a 30, but it's what? Negative. So you'll be where? Guys, you're down 30, aren't you? There's your triangle that works. So this will be what? 30 or negative 30? That's negative 30 or negative pi over 6. Good? This is Friday. Non-calculating. You can't touch it. Okay, keep going. D, E, go do E. Inverse sine of negative 1 over 1. Should be looking here, right? Are you finding it? I'm hearing 45, is that right? Opposite over hypotenuse. Opposite over hypotenuse. Ready? Let's try it. Nobody's telling me anything right now. Opposite is what? 1. Hypotenuse is what? Is 1 over the square root of 2 going to be 1 over 1? Guys, I know it's tempting to say 45 because you guys all want to say 1 over 1, it's 1, yeah, that's it. No, it's not. Because sine is opposite over hypotenuse, it's not 45. And it won't be this either because there's no 1 over 1. So what is it, Ray? Is it, he says, is it 90? He's saying, is it going to fall on the x-axis or the y-axis? That's what he's trying to say. Is it 90? Let's take a look. So guys, if it's not one of the triangles, it might be the unit circle. And by the way, this is sine. Sine is defined to be here, here, or here, here. And you have this, don't you? You have this. Right? Radius 1. You know what? If I look at that, I go like this. This is just y over r. Where's the y value? Negative 1. Brady said, is it 90? Is the y value going to make it negative 1? No. It's not 90. What is it? Isn't it negative 90? Because that would be 0, negative 1. The y value over the radius is negative 1 over 1. The answer was, you guys were supposed to say negative 90, or that. Okay? Good? Are you okay?
Yeah.
Those are kind of hard when you end up with quadrantals, the ones that land on the xy axis. Okay, do the next one. What is the next one? Oh, 1/2. Oh, we've already done this, haven't we? Have we done sine of negative 1/2 up there?
Yes.
What was it again?
Oh, we did.
Sine of
Negative
yeah, did we get that already? We got it right here. We did negative 1/2, which was down 30. This one would just be what? This one would just be up 30, wouldn't it? Okay. So this triangle, wouldn't this triangle create, sine would be 1 over 2. 1 over 2. Oh, so the answer is what? What degree? 30 degrees, or better yet, what radians?
5 or 6.
Pi over 6. I guess we didn't have to do a whole lot of thinking on that one, because we'd already done it. All right, inverse sine of 2. By the way, 2 is just 2 over what? So what is inverse sine of 2 over 1? Brady's hand is high up in the air. He's going to tell me something.
Isn't, like, that refer to radians? 'Cause isn't 2 radians past 90 degrees?
Oh, you're getting confused. You're thinking I'm saying find sine of 2 radians. I'm not. I'm saying inverse sine of the ratio of 2 over 1. Now the ratio of 2 over 1 means opposite. I'm giving you the opposite side 2. I'm giving you the hypotenuse 1. I need an angle that will give me this ratio. Just like all of these.
Rather than
There isn't one,
There isn't one, why not?
because there's no hypotenuse.
There's no hypotenuse that equals.
Because it
There's
says
no
2 over
opposite.
1 is opposite over hypotenuse, but there's no opposite that equals 2, except if we take.
Okay, so you're looking at your triangles, aren't you?
Yeah.
Okay, and I was hoping you would say that the longest side on a right triangle is what?
2.
The what?
Hypotenuse.
The hypotenuse. If the longest side on the right triangle is the hypotenuse, how is this going to work? How would the opposite side be longer than the hypotenuse? Is it going to work? No. Guys, this is a trick question. If you ever see sine or cosine, hypotenuse is always the longest side. So here's the deal. When you plug in numbers for your ratio, all your numbers have to fall between here and here. If you looked, I told you this on the first page. I said all your ratios have to be between -1 and 1. That number is bigger than 1. This won't work. Go ahead. Use your calculator. Inverse sine of 2. What's the inverse sine of 2? You're going to tell me what? Air. It's undefined. There's no angle. No angle exists. There you go. There is no angle. All right, here comes the fun part. Now go ahead. Use your calculator. Use your calculator to evaluate the expression in both radians and degrees, round to 2 decimal places. Now really what you guys are plugging in right here is this. What ratio you're plugging in? When you guys plug in 0.9, you're plugging in 9 over 10. When will the opposite side be 9 and when will the hypotenuse be 10? At what angle? You know what? When you have a calculator on your desk and you don't punch it, then you're just saying basically, I want to steal everybody's answer. Would you start punching your calculator? What's the answer?
Punching my calculator.
Yes.
Maybe it's 64.
60 what?
I think it's 64.1 something.
1/6? Okay. So there is the angle that creates that ratio right there. Okay. How do you get the radians? You could convert if you wanted, or you could just take your calculator, shift it over to radians, punch it back in, and get what?
-1.
1.12.
1, 2.
Okay, good. That's what Brady says. Is he right?
Yeah.
Okay. Okay. All right, move on. Now do tangent in degrees, tangent in radians. 23 what?
0.75.
0.75. Okay. In radians. What did you get, Brady?
415 rating.
415?
Yeah.
Could I say 4.2 then?
No, it's 4.
It's what?
It's 414.
414. Oh, okay. Sorry. 414 makes 41. Okay. So basically, that many radians and that many degrees. Are you okay?
Yeah.
Now, why? Hey, why did they let you do that? Okay, guys, why did they let you use your calculator? Because those ratios are not your special triangle ratio. So guys, if you don't have a special triangle ratio, you have to use your calculator. There's no one in this world that can get those answers when it's not this special kind.
But you start on.
That's why you want your calculator, some, most of it. You think Brady can do it?
I think Brady can do it.
Yeah, right.
Brady, they got a lot of faith in you, Brady. Brady, put your calculator upside down, quick. What's inverse sine of 0.1? Let him think about it, let him think.
Great start.
Here's your assignment, by the way. The yellows, all yellows.
You need me one, Amber?
Sorry.
You guys all have feet, don't get up here.
Sorry, I didn't know you said that.
Hey, go watch my Vine. I saw it.
Yeah.
Hey, go watch my
That's
Vine.
what I
It's hilarious.
Did it say,
What's my first Vine?
did it say worksheet, numbers, this through this?
Oh, no, it's a done.
Book and worksheet.
Yep.
Let me look.
Okay.
Oh, this stuff looks so easy to do. 9 over 10. That always equals 6. See you, Jay Gills.
Yeah.
That was cool.
Is that like the band music room?
I'll show you.
R.
That's
That's not good.
And you got Thursday and Friday. Sorry.
That's all right.
I did. Yeah, we didn't know what
You can do it.
I guess we'll try to call her.
Hey, I'm looking for Emily. You're gone tomorrow.
I'll
You might
just
want
show
this
you
too,
what
she's
goes
gone
on.
too.
Okay, turn on you learn.
Oh, you want to That was a big
You're here Thursday.
We'll see. Like, how did you do things? Oh,
Dude, is this yours?
apparently.
Oh, Brock, put it on.
Put it on.
I heard this is
What is
easier.
it?
Loss.
You put it on now.
She's like, no.
Oh,
That's
put it on.
This is insane.
What?
I want to look at it. I'm trying to look at the market.
Isaac, put it on. Selena, put it on. It's a
That'd be
bit
weird.
tomorrow.
That's in the books.
Everything.
Put it on.
Hey, did I just give you 14-2B?
Yeah.
Okay, got it.
Trying to find that droid thing you said.
What do you mean?
No, you won't. You're not gonna put it on. Just gonna throw it at me. You're gonna like put it on me. Just enjoy it. I made a bind, dude.
They mean it looks like a
Yeah, I can figure that out.
Looks like a droid.
Like legit.
Like the
That looks good.
Ew. That is a droid. I used to have like a phone like that.
It sucks. Like I think I'm using a drag right now.
Wait, let me see. Like the spelling, like the words are mine. I mean, droid.
Yeah, Barry went out there, but it's way quicker.
Oh,
Is it that much quicker?
Is it way quicker?
Was it so effing slow to begin with? I just use it as
It's hard to explain.
Go to the bathroom.
Let's see.
Jumpsuit, bro.
Okay.
I am wearing a jumpsuit.
Nice.
I'd like an actual high five, please.
Yeah.
Will you use it? Just kidding. That was doing serious. You put it on. I'm not putting it.